Hi everyone, and welcome to my first technical blog. You'll have to bear with me, I've not done this before, so you're coming along for the ride with me learning how to blog as well as the technical side. Let me introduce what I'm trying to do. So by day I'm a software developer, by night I'm a frustrated electronics engineer, likes to tinker with electrical things, and I'm a reasonably new beekeeper of 2 to 3 years, albeit some of that time working with a commercial beekeeper, so dropped in at the deep end. I've got hives, and a lot of them aren't where my home is, and one of the things I worry about is having the hives tampered with or pinched altogether. There's been quite a bit of that going on recently around our area. So I'm coming up with a technical solution to protect my hives, but also to generate some interesting data from them as well. So if that's your thing, by all means follow along. If I get enough follows, likes, comments and whatever, I'll carry on blogging. I'm going to carry on doing this anyway, but it's whether I blog about it or not. So let me know feedback, what you think. Sorry. The plan is I'm going to build little devices that go on the side of my hive. This one's 3D printed, which monitor when the hive's been knocked or moved or disturbed in some way, but also monitor what's going on in the hive. So there's lots of things that we can monitor, such as the temperature, humidity, activity on the front of the hive, sound. You can monitor sound. There's various ways to detect swarm warnings. There's a lot you can detect. There's a sensor for just about everything now, right down to air quality, light levels, light colour. Just about everything can be monitored now with very, very cheap sensors. So here's an example of a temperature sensor. It's temperature, humidity and air pressure. Costs £1 or £2. You can put one of these on the outside of the hive and know the outside environment, but you can also put one inside the hive and monitor the quality of the air, the temperature and humidity inside the hive as well. Likewise, there's little sensors that detect knock. This is a little spring encapsulated in a coil, and if anything knocks the hive, whether it be an animal or whether it be somebody tampering with your hives, this will pick that up. So how does all this work? Well, everything comes down to a microprocessor. Now, if this isn't your bag, sorry, I've got the COVID cough. If this isn't your bag, then you're probably going to have to do a bit of learning. But the learning isn't substantial, and if you're interested in this sort of thing, it's quite straightforward. So these are microprocessors. This is a very simple one. This is called an ESP8266. This is model 1. This has a couple of input and output pins, and what this allows you to do is to write code that can detect things like a knock, and you'll notice up the top here there's a Wi-Fi antenna, and what this can do is detect a knock and send a message over the Wi-Fi to an app or a cloud-based system. As I say, don't get phased by any of this. It's reasonably straightforward, and if you've learnt beekeeping, this will be no problem to you at all. These things cost about £1.50, and all these internet connected lights, air conditioning systems, etc., tend to use a very similar chip to this. This one only has a couple of pins. It's very cheap. It's very good for switching things on and off remotely, but it's limited to what you can do with it. The next one up is still the ESP8266. You'll notice it's very, very similar. It's just a slightly different package. This has a lot more pins, and you can see from the size of my thumb, these things are really tiny, and they use tiny amounts of power, and you can monitor an awful lot of things with this. So one of these is capable of monitoring all your temperature, pressure, humidity, any movement, any light levels, air pressures, and just about anything you can sense can go through one of these. And this can connect through Wi-Fi. Now, some of you are probably already detecting the problem. If you've got an apiary out in a field, Wi-Fi is not much good to you, but I'll come on to that. If you've got your hives at home, you probably don't need to monitor them quite as carefully anyway, but it might still be interesting. Now, these are wonderful. They're microprocessors that you can write code for. They connect to Wi-Fi, but they're not everything that you need. The problem with these is they need power within very, very fine tolerances. You also have to find a way of connecting to them and coding them. So generally what happens is these chips get mounted on a supporting board. Now you'll recognise the chip there. It's the same chip, but on this board there's a connection that allows you to plug it into your computer and write code on it so you can program it. There's also power regulators. There's a connector here for a lithium-ion battery or a solar panel. Again, we'll come on to that. And lots of simple connections that you can then connect sensors to. This one is a Hussar feather. There's lots of models of these, hundreds of them literally. There's one that has a particularly low power usage, which I'll come on to later in another blog, which I'm looking at the moment. So you've probably picked up from that power is one of the problems. These things will run on 2 AA batteries for months if you put them into sleep mode. So if you leave them running, they'll flatten out in a few days. But what you do is they have a timer in them, and you can say to them, go to sleep for an hour, wake up and take these pressure sensor readings or whatever readings you want, send them to the cloud, and then go back to sleep for an hour. The other thing about that is you can also have them so that if something knocks them, so if a sensor picks up, then it can wake the processor and send that message. So what I'm planning to do is to use these for monitoring the hive, but also have the knock sensor so that if something knocks the hive, it will wake this up, send the message, and this all happens in milliseconds. Send the message and then go back to sleep again and carry on monitoring the hive every hour as I've asked it to. How do you get into these things? Well, the simplest route is with this board here. This is called an Arduino. I think it's about £25 to buy. They're wonderfully simple. They were developed to allow people who don't program and don't have any coding knowledge or any huge technical knowledge to get into this type of thing. So there's hundreds of courses, there's hundreds of online tutorials, and if you've got no knowledge of coding and you want to get into this type of thing, this is a great place to start. This has a lot of problems too. It's designed to be powered from your desktop. It hasn't got a Wi-Fi or an internet connection, but it's very forgiving. You can do a lot of things to these boards, make a lot of mistakes, connect things wrongly, and it will let you get away with it. Whereas the ESP8266, slightly less forgiving. The other thing you have to watch between these two boards, and God knows why they did this, the Arduino is 5 volts and these are 3.3 volts, and while it doesn't sound like a big difference, if you put 5 volts through one of these, it will blow it. So you'll blow a few of these messing about, but that's how you learn. So if you want to get into this and you've got no knowledge, get an Arduino, do some of the courses. Fantastic fun. You can control all sorts of things. I bought a cat toy that was completely useless, and by putting one of these in it, actually it was an ESP8266, by putting one of these in it, I turned it into a really great internet connected toy for my cat that was clever enough to avoid my cat. So you can have a lot of fun. It might not be your idea of fun, but it is mine. So that's your ESP8266. Uses a tiny amount of power. You can connect all sorts of sensors, and it can connect to Wi-Fi. So you've probably detected the flaw here, and that is that out in an apiary you probably don't have Wi-Fi. So let's move on to that. Next up from the ESP8266 is a very similar processor called the ESP32. It's a lot more powerful, has a lot more pins, so if you start to run out of pins on the ESP8266, this one will take you that bit further. Again, this is the chip and this is the supporting board. There's your power regulator and there's your USB for coding it. Along with the extra power generally comes with more power consumption. So I would say, and a higher cost, and I would say therefore that you're better to go with the minimum amount that you need to get the job done. This isn't the minimum amount, this is quite a bit more powerful. But the beauty of this one is that it comes with an upgraded board, which is called the TT Go T-Cool board, and this has a GSM SIM card slot. So there's my SIM card, and this allows me to connect to the internet or send text messages. It can actually send voice calls as well if you really wanted to record something and have a recorded message come through to you. And this allows you to be out in the middle of pretty much anywhere where there's a mobile signal and send data back. So my plan, and I have it working in a basic form, is to have these on each hive and then one of these in the apiary. Now, the ESP chipset comes with a thing called ESP Now, which is a really simple, lightweight messaging service. So it allows any number of well, it's about 128 off the top of my head, but I doubt you're going to have that many of these monitored at any time. And if you do, this is going to be the least of your problems. It allows up to 128 of these to connect to this. The problem is that these wake up every hour. It's not an exact hour. You haven't got them synchronized, so you never know when that message is going to come. So this one, acting as a sort of gateway or a server, has to stay awake all the time. Now, as I've said before, battery problems are always at the top of your mind with these things. This thing can't go to sleep, so if I put a normal set of batteries in it or a lithium battery in it, it would probably last days, possibly weeks, but it certainly wouldn't last much longer than that. So what I'm working on is using, I think this is a motorbike battery. It's what a lot of the scarecrow guns use in the field. You often see farmers driving around with 20 or 30 of these in the back of their car. So it's a 12 volt lead acid battery. It's got normal sort of connections that you would expect. And what I've done is I've 3D printed a case that goes on the top, which holds one of these boards in the top, and then connects to the battery. And if I just lift my phone up slightly, it goes over the top of the battery. You can strap it round, and this can sit in a field for potentially months and months and months, acting as your gateway to the internet. And that has another advantage. Because it's always on, we can add a few more functions that we wouldn't normally be able to do with a device that goes to sleep. And this little gadget really intrigues the hell out of me. Again, it's a couple of pounds per board, and it's a microwave Doppler sensor. So what it does is it sends out a microwave signal, and then it detects the frequency shift in the reflected signal. And what I've done is I've put a little mounting place for this in the top here. And what it does is it sends out a signal all around it, and it picks up anything moving, anything of a substantial size moving, and you can adjust that sensitivity. So effectively, it can go in the top of the battery cover very discreetly. You can even hide it in a feed bucket, because one of the advantages of microwave is it can see through things. So unlike these passive infrared sensors that you get on alarm systems, it can work through this plastic. There's certain things it doesn't work through very well, metal for example, but it does actually still see through things. So you can hide it, and just because this is on all the time, if anything moves in the apiary of a substantial size, it might be a deer, but it might also be somebody tampering with your hives. This thing will pick it up and send a message through to you instantly, so you can send yourself a text message saying somebody's tampering with the hives or something's moving in the apiary. I'm not entirely sure how the bees are going to accept a microwave signal in an apiary. I'm going to watch that fairly carefully. So as soon as I've got this up and running, I have tested it, but as soon as I've got it running in a decent way, I'm going to pop it in front of a hive and just see what they do. It may be they don't detect it at all. It may be that they don't like it. Passive infrared, the traditional sensors that you get on alarm systems, only receive and they pick up on heat signatures. So I'm feeling that they'll be more bee compatible. But I'm going to give this a try and just see how it goes. You're welcome to come along for the ride. If you've got any experience of using this type of thing, certainly give me a nudge, and perhaps we can see where we go from there. Just to finish off, the way I'm powering a lot of these things is with a lithium ion battery. These batteries, the 18650, they're famous. They're in just about anything that has a large amount of battery power. I'm told the Teslas batteries are made up of literally thousands of these. I'm not sure how accurate that is, but I know that my electric scooter has about 40 of these all just sort of welded together. They're rechargeable. They pack quite a punch, 4,000 milliamp hours compared to a normal AA battery, which is typically 1,500, I think it is. They have a voltage range which is compatible with the ESP8266s, and typically I would expect this to last probably a year or more on a Hive monitor. So that's the type of battery I'm looking at. I've got a number of other batteries which I'm playing about with. Here's a traditional lithium ion. This one's 1200 milliamp hours. So you can see, you know, while it's flat and fits in the case nicely, it doesn't pack anywhere near as much punch as these 18650s. So let me know what you think so far. If lots of you are interested, I'll carry on blogging and let you know how it goes. If I don't hear a word, then I'm going to carry on doing it, but I won't bother with the blogging. Any comments on the blogging, any help, any advice, let me know. Thanks a lot. Bye.